All right, class, we're back with our section 4. What we're going to call section 4 is using U substitution. All right, so this is going to be probably the hardest thing in the unit. So feel free to go back, rewind this video, watch it again if you need to. All right, so the first thing, if you guys remember when we did definite integrals and indefinite integrals, we talked about what happens when we have something like this, right? We know that the integral of e to the x dx is just e to the x, right? Oops, sorry. It's just e to the x. But if we have this, we need to do something about the 5. And so when we took integrals, we talked about how it was, instead of multiplying by 5, you do 1/5 e to the 5x plus c. All right, but what I'm going to show you is how to do this with U substitution. So what you would do here is you would say let U equal 5x. So U is going to be like our new variable. So du then, like the derivative, so remember this is going to be the derivative, well the x goes away and we have 5 dx. All right, now if we looked at this integral, in order to rewrite this in terms of u, so we're going to call our variable u, we're going to have eu du. All right, but we need a 5 here in order, because if du is equal to 5 dx, well, we only have dx up here in the beginning, so we need to put a 5 here. And in order to do that, you have to multiply by 1/5 on the outside. Okay, so just remember that in order to put a number inside, we got to do the opposite operation here, because then it cancels each other out. So really what this was saying then, well, eu du, when we take the integral, right, we're just going to have e to the u, and we're going to have the 1/5. So the 5 and the du are going to go away, because when you take the integral, and because of the 5 here, and the 1/5 will remain. And then if we go ahead and we say, well, u is equal to 5x, then our final answer is 1/5 e to the 5x dx. Or sorry, not dx, plus c. 1 second there. So 1/5 e to the 5x plus c. Now here's a case where it's like almost harder to do it with u substitution, but you see how it works. So let's look at a couple more examples using U substitution. All right, so if we're going to, here, we're going to go and we're going to say let U equal. Now what you typically want to do in these types of situations is let U equal whatever's inside the parentheses, or a square root, or whatever's in the denominator. So we're going to have a couple examples of each of these. So in this case, we're going to say let U equal x squared plus 1, and it's not going to equal cubed, it's just going to equal the inside part. Because what we're really looking at is like there's no way to take the integral of this in its current state. Okay, so du, right, would be equal to 2x, right? So this is going to become 2x. This is the derivative, remember? So this is the derivative of u. All right, so this is going to equal 2x dx. All right. So you can see here we have the x, but we need a 2, right? So we're going to put 1/2 on the outside, 0 to 1. We're going to write our 2, and this is fully counteracted. And then we have x squared plus 1 cubed dx. All right, so what's going to happen now is that we're going to now convert this into u form. So, or using the u. So now we're going to say instead of x squared plus 1, we're going to have u cubed. And then the 2x and the dx collectively are going to form du. All right, and then we have our 1/2 outside. So now we can take the integral of u, okay? So the integral of u would be 1/2 times, that would be, remember, then we're going to add 1, divide by 4. So we get u to the 4th. And now we got to switch, since these are actually in terms of x, we got to switch back to x. So now we're going to go back here and we're going to say, okay, well that's really 1/2, 1/4, x squared plus 1 to the 4th, okay? And now, since we're back in terms of x, we're going to say this is 1 and this is 0. So that's going to give us 1/8 x squared plus 1 to the 4th from 1 to 0. And now we would input our number, and we're going to get a final answer. All right, now what you can do is you can put this in your calculator to check your answer at the end. But I'm going to input, first I'm going to input 1, so that's going to become 1 squared plus 1 to the 4th minus 1/8 of 0 squared, which is just 0, plus 1 to the 4th. Okay, so this is going to become 2 to the 4th, because 1 squared is just 1 plus 1 over 8. So that's 16 over 8. And then this is just going to be 1/8, right? So our final answer, 16/8 minus 1/8. And when you're all done with this not that easy problem, you have 15 over 8. Okay, so to recap, the things you want to think about is writing this in terms of u and du, and then we use u as our variable, and we do the integral, and then we convert back to x, and then we input our numbers, right? And in this case, whatever was inside the parentheses became u. So final answer here is 15/8, and you can check that in the calculator, and you would get that correct answer. Okay, so that's the first one. Feel free to rewind and watch again. And here's the second example. Okay, so like I said before, we want to use what's on the inside the square root of parentheses or what's in the denominator. So in this case, we're going to go with the square root. So we're going to say let u equal 2x plus 1, and then du is going to equal, well, the derivative of 2x becomes 2, and then this would go away. So we have 2 dx, all right? So we already have our dx, but we need a 2 here. So we're going to say 1/2 from 1 to 3, 2 times square root of 2x plus 1 dx. All right, now I'm going to rewrite this in terms of u in a second. But before I do that, I'm going to say, well, from 1 to 3, I have my 1/2, and I'm going to say 2x plus 1 to the 1/2. Because then when I go put in the u, it's a little easier. And I'll put my 2 dx here, since that's going to become du. All right, so now we're going to convert to u form, or do u substitution, as they call it. And that's going to be from 1 to 3, u to the 1/2 du. Right, so the 2 dx becomes du. That. So now we add 1 to both, right? So now we're going to say that's going to become u to the 3 over 2. So that's 3/2 over 3 over 2. And remember that we have to flip the fraction and bring it up top. So we're going to have 1/2 times 2/3 u to the 3/2. Right, so this is just going to become 1/3 u to the 3/2. Right, and now we can go and get back to and input our 2x plus 1 for u. So the final thing we have is we have 1/3 before we go input our numbers, 2x plus 1 to the 3/2. And that's from 3 to 1. Now here you're going to start to use your calculator, okay, because this is going to give us a decimal answer, and you can just round to the nearest 3 decimal points. So I'm going to input my numbers. I'm going to get 1/3 times 2 times 3 plus 1 to the 3/2 minus 1/3 2 times 1 plus 1 to the 3/2. Okay, so at this point you would have 1/3 times 7 to the, that's a 7, sorry, to the 3/2 minus 1/3 times 3 to the 3/2, 3 over 2. Okay, and then if you put this in the calculator, that's what I would do right here, because you're going to get a decimal answer. You get rounded to the nearest 3 decimal places, 4.441. right? So that's our final answer. All right, so we represented this as u, converted into a fraction here with the exponent so that we can take the integral. Then we simplified, and we let u, since u is equal to 2x plus 1, we put this back in and solve from there. Okay, one more example. So these are the first 3 problems from the homework. All right, so this one, this is a hard one, but anytime you see anything in the denominator, you're going to let that equal u, because what we're going to get is some sort of ln situation. Okay, so u is going to equal 1 plus sine of x, so then du equals cosine x dx. Right, when you do these and you take the derivative, if you don't see it in the problem, outside of a number or a constant, that's when you want to think about, am I approaching this correctly? Okay, so this is going to become du, and then this will become u. So let's rewrite this in terms of u. We're going to have from 0 to pi over 2, and we're going to call this 1 over u, because that's going to be u, and then du. All right, now you remember from the rules that natural log of u is the integral from 1 over u. Okay, so once we get to here, well, now we're going to go back and we're going to input ln, natural log of 1 plus sine of x, and now we can input our pi over 2 and pi divided by 2 and 0. So we're going to say ln of 1 plus sine of pi over 2. And if you know how your sine graph works, you know that this is equal to 1 minus ln of 1 plus sine of 0, which is going to be 0. All right, so this becomes ln of 1 plus 1. And then this is minus ln of 1, because this is just 0. Well, ln of 1 is also equal to 0, so that just cancels out, and we're left with natural log of 2. Right, so you could leave your answer like that, or you could write it in decimal form if you wanted to. All right, so that was kind of quick, but feel free to review these videos. And this is the first 3 problems, I believe, on the homework, so you have about 10 more of these to work out.